Welcome to Code Club. Today we are going to talk about generics in Go, which is going to be fun. I'm joined by Andrew, Dave, Mr. Parish, Thiago, Thom, Umang and Vignesh, which is a highly distinguished panel of gophers to help me discuss this important subject. Welcome. Thanks for joining. Now, if I have some news and some good news about generics. So, the news which you might already have seen is that generics are now a feature of Go. They're a fact on the ground. So we're going to find out today what that is. And the good news that I have for you is it's not that bad. It's not that bad. It's something, we're adding something to Go, but probably less than you think. So we might just frame this discussion, and I'd like us to try and do a little generic programming today. So first of all, we might just circle around and get an idea of what that means. So would anybody like to ask? We might collect a couple of questions about generics, mightn't we? And then we can try and answer them as a panel. Does anybody have anything they would like to ask? And the more basic the question, the better, as far as I'm concerned, because any question you might have, I guarantee you, hundreds of people out there will have the same question. So, what's on your mind?
I've not heard about genetics much about especially with respect to Go, what's the use of it. But I have used interfaces. So from what I understand, interfaces provides the flexibility for a Go program. So what does generics offers on top of or other than what interfaces provides?
Right, great question. Yeah, I was hoping someone would raise that. Anyone else?
I've got a question of how this is going to change. You're a big advocate of test-driven development, but what is a test for something? I kind of familiar with generics from other programming languages, but
Right.
What is that? How is that going to impact testing? Test first and then write the function for it, with different data types and stuff like that.
Yeah, that's a really good question. Yeah, I've been known to bang on a bit about test-first development, haven't I? So this is definitely going to be a factor. So let's try and tackle that. So, any more?
Yeah. So what's the difference for generics between runtime changes? So how the actual running of your program versus how the compiler deals with it at compile time.
Right. Another excellent question. Let's see if we...
Well, I have a comment about it. So for me, the only advantage of generic I have seen so far is that instead, if you have a type that can receive different values and you want to create a method, not a type, a struct, and you create a method on it, if you need different types, you're going to have different methods. But with generic, you can have just one method that can receive different receivers, like the another type or something like that.
Yeah. Yeah, let's take a couple of minutes to assume not everybody knows what we mean by generics and just recap that briefly. So one a really nice definition that I've seen of it, which is due to Ian Lance Taylor, is he says, generic programming means writing functions and data structures where some types are left to be specified later. That's an interesting way to put it, isn't it? So already we're seeing a slight difference from interfaces in Go, because we know there are things in Go called interface values, and they are values of which we don't know the type at runtime. Empty interface, for example. We can have a value of empty interface, and we know nothing about it at runtime, and we can try and assert things about it. Generics are different. So generics is not a runtime thing. It's purely a compile time phenomenon. So a generic function, for example, is one where, as Ian Lance Taylor says, we leave one or more types to be specified later, and they will be. That's the point, isn't it? And similarly, a generic type is, let's make this concrete. So let's think about an example of the sort of thing we might like to do. So suppose suppose we wanted to create some type bunch of, you know, like a slice of int, let's say, and we would like to be able to create a bunch like 1, 2, 3, and let's print it out. I think this will work. We're not into the generics yet. Yes, that's encouraging, isn't it? It's when things like this don't work that you know it's going to be a bad day. But we're happy with this, and this works for ints, but of course if we wanted a bunch of floats, we would have to do something like this, and this is very unsatisfactory because we'd kind of like to write a generic collection type, wouldn't we? A generic bunch, a bunch of any type, and one way to do that might be to use interfaces, right? So we could define something like this. It's a slice of what? A slice of empty interface. So as we were saying, this represents some value whose type is not known at compile time. So that's all right, but very inconvenient, because in order to actually do anything with this stuff, you know, imagine you write a function which takes a bunch and does something to each value, let's say, or reverses it, or finds the maximum, or the first, or the last. These things are very awkward to do because with an empty interface value, you can do nothing with it until you've type asserted it to some type that you can do things with. So all of the impetus is on you to work out how to deal with this thing. So in general, that's the only time we use empty interface is when someone from outside is giving us some value that we don't know about. We would never write this kind of thing internally in our own programs because it's just super awkward to deal with. What we would like is we would like to be able to say a bunch, let's say a bunch of any arbitrary type, let's call it T, is a slice of T, right? Does this seem reasonable to anybody? It's not outrageous, is it? So could we do that? No. One thing is we need a little more syntax here. So this is the syntax for declaring a generic type. We can't just say T though, we need to say something about it. Like, one thing we could say about it is nothing. So if we write any, we're saying for literally any type T, it's all right, we can just create a slice of it. And that's fine. So let's have a look. No, all right. We can't just, we've referred to bunch here, and we've given it a bunch literal, but that's no good because we need to say what type of bunch it is. And in this case, it's int, isn't it? So that's all right. So now we can create this generic bunch type. So that's fine. Can we have a question or two on this, and then we'll try and build on that a little bit.
So when you're defining what a bunch can be, in this case you said it can be anything. Are there other keywords other than any that are we would expect to be in common use that define like a limited scope?
Nice question. Yeah, that's clearly, I mean, the fact that any exists sort of suggests there must be other possibilities, doesn't it? And you're absolutely right. So we'll get to those in a moment. But just as far as this goes, who would like to ask something?
if I can use the append to add another int, like it's normal.
Oh yes, yeah, let's try. So we think we ought to be able to do something like this.
Yep.
Yeah, we can. So that's fine, because actually this is just a slice of int. And we're familiar with those. Or at least they're not so scary. So, you know, what we're saying is we don't have... There's no such type as bunch, right? This is one way to think about it to yourself. There is actually a type called bunch of int. We've got one here. So this is a type. And here's the literal. But there could be bunches of other things. So we could also imagine defining a bunch of string. Fine. Print that. So that's okay too. And this is just a slice of string. Effectively, you know, that's its underlying type, isn't it? So that's all right. So this syntax actually doesn't look that threatening, does it?
One more question. I know I can print because it's an interface, but what would happen if I print just bunch or just B? Oh, no, because the instantiation different variables. There is no way.
Yeah, well, let's try and explore that by saying, so, you know, fine, what can we do with this bunch? Well, we can pass it to functions like the thumped family, which take anything. But let's suppose we wanted to write a function which takes a bunch. What would that look like? So suppose we try and write print bunch. You know, something like this, or just print bunch B. That should print something, shouldn't it? So how can we write that? It's going to be some kind of func, print bunch. Let's say, you know, let's see if this will work. It won't, but let's try. So let's range over the bunch. Print each value. No, this is not going to work because, as we were saying, there's no such type as bunch. There's only a bunch of int or a bunch of string or whatever. So what we're saying is for some type t, any type t, we take a parameter which is a bunch of t. That's a little more complicated now, isn't it? But we can still understand this. So does this work? Yeah.
So scoping for the type is also at the function level, i.e. the t of type that, you know, the any scope you can apply at both the function level and the type level.
Yeah.
Or type declaration.
And let's just get rid of bunch and just say, you know, so ignoring bunch for a moment, we just have some print bunch for any type t takes a slice of t. That's all right, isn't it? Let's just make this a plain old slice of int now. So let's call this print slice. Right. All right, so this looks all right, doesn't it? So we had a generic type, and we wrote a function which takes slices of that generic types, which is one kind of generic function, and this is another kind which just is simpler because it just takes a slice of any type t and does something with it. So this is all right. So do we have a question on this?
I think this answered my primary question, which was, did we need to have type declaration of a generic type like bunch versus handling native types, which is what this is exactly what I was looking for personally.
Yeah.
Which is I mostly want to do stuff with native types, or commonly, or like slice style helpers that don't exist today.
Yeah. So this is nice, and this syntax isn't all that scary, provided we know how to read it, and you'll be delighted to know that basically this is it. This is the extra syntax that's been added to Go to support generics. There's actually one extra small thing which we'll come to, but this is the bulk of it. It's square brackets, basically. That's what it is. So I think so in a sense we've changed the syntax of a function signature such that we already know that a function signature has a name and a list of parameters with their names and types, optional list of results with their types, and if it's a method, then one of the parameters goes in front, also inside parentheses. And we're adding yet more brackets to this by putting square brackets in here. So you could, in theory, have 1, 2, 3, 4 lists of parameters in a function signature, which is a lot. That's slightly more than I'd prefer, but here we are.
Can you provide multiple types? So basically, can you say, hey, I'm going to take in 2 parameters that are, and essentially scope the generic type differently for each parameter?
Yeah, something like this.
Yeah.
Yes. So let's say, we take a slice of t plus a suffix of type t2, and then we print the suffix after every value. Let's try that. Yes. So just like with normal function parameters, we can take any number of what's called type parameters, and they can be different. They don't have to be any, and we'll see what else they can be in a moment. So let's suppose. So again, this is fairly trivial because all we're doing is ranging over a slice of whatever it is, and we don't actually need to know anything about the type to do that, which is why this works. So let's do something more. Suppose we wanted to write a function like equal, right? Suppose we were writing a testing framework and we want to be able to say, equal x1, let's say. We have some x. Now, it's not hard to write this for integers, of course, or for strings, or floats, or any other type that you care to mention, but to write it for any type is a little more challenging, isn't it? So let's try. Thom, perhaps you'd help me here. Can we build this up step by step? So we know its name is going to be equal. What else do we need here?
We need to define that this equal is going to take in the generic value and define, so in brackets.
Yeah, so we have something here.
Yeah.
Let's call it t.
T of some scoped value. I happen to know where this is going. I don't know if you want me to say, or
Right.
not.
Let's start with any, because we know any, and we'll see if this works. And now that's fine. So that's the type parameters. What are the input parameters?
We're going to take in two values of the same type. So say A and B of type T.
Right.
And we'll return a bool.
Yep, that makes sense. And it's pretty easy to write this, isn't it? No surprises, so let's have a go. Ah, we have an issue. So let's unpack this. So cannot compare A equals B. Operator equals equals not defined for T. What does that mean? So it means these are ints, right? Let's say. So there's no such function as equal, but there is an equal int, equal of int. If you want to think about it that way, we can even write it explicitly. It's the same. The reason we didn't have to write that is when it can be inferred, it will be, and it can be inferred because the compiler knows these are ints, so it will call equal int. That's all right. So we've said that for a type T which we know nothing about, here's the function. Well, compare these two values of type T. But there's a slight problem there because values of not just any type are comparable, are they? Which is to say we can use them with the equals operator. Anybody know what is and isn't comparable in Go? So what values can we compare with equals equals? Any suggestions?
Floats and these sort of basic types.
Yeah. Yeah.
So can you compare compound type structs?
Structs you can compare, yeah. Structs are equal if the values of all of their fields are equal. And things that are not equalable include maps, slices, which is a shame. We'd love to be able to compare slices, wouldn't we? It's not like we can't write a function to compare them, for sure, but we just can't use the equals operator. And some other things, functions, for example. So what we're saying is that actually any is not quite good enough, isn't it? Not just any type is usable with equal, because with, if we tried to call equal with slices, it just wouldn't make sense.
So we need to explicitly specify the type, right?
That's right. We need, this is called a constraint. So this is saying, telling the compiler only types which satisfy this constraint are acceptable here. And we're already kind of familiar with constraints because interfaces are constraints, aren't they? Like we can already write functions which take, let's say, IO reader. We don't know what concrete type that is, but we know it satisfies the IO reader interface, which is great. What is that interface, though? What does it specify about the type? Well, it specifies that it has a read method. So that's useful for things like that, but it's not going to be so useful here because actually this isn't a method. So, if we'd love to write an interface which says this type can be used with equals equals, but we can't do that because it's not a method call and interfaces apply only to methods. We need some way to express that constraint, and the way that we do that is to use the new keyword comparable. Actually, it's not a keyword, it's a pre-declared identifier, I think. So, great. So actually now this works because we've promised the compiler that for any type T where you can use equals equals, it can do this function, and it can. So that's great. Let's see if we have a question about this one, and then we'll try and do something.
Yeah, I have a question. If we pass a non-comparable type, it's going to, I assume it's going to crash at runtime error, but...
That's a great question. Let's see. Let's use slices since we're saying we can't compare those. These are visibly equal, but all the same, Go won't let us do that because slice of int does not satisfy comparable. And that makes sense to us now, doesn't it?
Yeah, and I'm glad it's not allowing me to compile the program.
Right. Because it's all very well for things to crash at runtime, but we would prefer for them not to compile. Or at least, when you're first learning Go, I think you'd like all your programs to compile. And you're very angry and puzzled that they do not. But ultimately the compiler is your friend. It just has a weird way of making friends, doesn't it?
Later on, we appreciate this.
Yeah. The compiler's like a grumpy sociopath who won't let you get away with anything. But ultimately it's for your own good. So learn to love the discipline. So this is great. So let's try and do something a bit cleverer. As maybe for some slice type, we might say, could we write a max function which returns the maximum value? So let's suppose we had, a slice of ints 1, 2, 3, and we want to print the max of x, which we feel instinctively should be 3, but this is something that's quite difficult to write in Go without generics. Perhaps I can call on Mr. Parish. Let's start with func.
So I think the function name.
Yeah.
And then the
we're going to have something here, aren't we?
Type constraint, yeah.
Yeah. So t something. Let's say any for now, and we'll see what we can get away with.
And then the function arguments or the parameters. Sorry.
Yeah. So is it? So this applies to a slice, doesn't it? So
a slice of
let's call that S. Yeah, slice of t. Sounds delicious. What do we return?
Maybe just a T.
T, isn't it? That's right. So we have several T's, and we're going to find the maximum one, and that's what we're going to return.
Sure. Yes.
Good. Okay. And we would know how to write max for some known type, wouldn't we? We'd have some variable which stores the current maximum that we found. We know that's type T. We would range over this slice, and for each one we'd say, is it greater than the current max? Because if so, it just became the new max. And this is fairly familiar, isn't it? We'd have no problems with this if we just knew what T was. So let's see. Yeah, this is not going to fly.
So the comparable constraint we had before still doesn't encompass greater than and less than, although those are obviously comparable as well from a sort of a logical sense. So
it's a good suggestion. Let's try comparable and see if that helps, because we already knew any wasn't.
The problem you do, it doesn't accept a slice.
So you're expecting that if something is comparable, which is are they equal, that is also the same as greater than and less than, which is ordering. And so from a type theory perspective, you could say those things are different. Things that are equal are not necessarily orderable.
Yeah.
And max, less than, greater than requires order.
Yeah, I think that's a great way to say it. So what promise does comparable make? It only promises that we'll be able to use equals equals. That's it. We should probably call it equalable or something. But apparently that's not a perfectly cromulent word. So comparable is what we have, but we sort of think of greater than and less than as being comparing as well, don't we? Even the compiler does. But it's the same complaint in essence, isn't it? It's saying you gave me some T, I didn't have enough information to guarantee that I'd be able to use the greater than operator with it, so I won't. We're not at home to Mr. YOLO. We're not going to just try it at runtime and crash if it doesn't work. Otherwise we'd be using C++. So what promise can we make which guarantees that we can use at least the greater than operator, if not the less than operator. Any suggestions?
But one question, you said that slice is not a comparable type. Why it's not complaining about it?
Because we're not using equals equals.
No, the compiler shouldn't complain as when you try to pass a map, it failed, right? The previous time.
Yeah, so I think you're asking, we're passing a slice to this function, and we're saying the type constraint is comparable, but a slice is not comparable. Is that right?
Right.
Yeah, perfectly true. But t is not a slice. T is actually int in this example, and our parameter is a slice of t. So we're saying for a slice of whatever it is, here's the function, and the constraint on whatever it is that it be comparable. So a slice of ints would be fine, a slice of structs would be fine, a slice of slices would not be fine. Or a slice
like
of maps.
A for each, something like that.
Yeah. So that's a very good point. So it's until we're used to reading function signatures like this, I think it'll need a little more effort than we're used to. And of course this could get much more complicated, but should not, I would argue. I mean, it's possible to write complicated Go code without generics, that's for sure. But we try not to. So we would do the same with this feature, wouldn't it? So what could we do here? Could we use any? Clearly not. Could we use comparable? Now we know we can't. Can we use an interface of any kind? No, because we're not talking about a method set, are we? We could define some type of our own, which has a method called greater than, and then we could make an interface which is the method set greater than, and then we could add that constraint to this max function, and that would be fine. It just wouldn't work with ints, which would be rubbish, wouldn't it? So we'd like to do better than that. And here's the last bit of new syntax that I didn't tell you about, is we, as Dave rightly said, what we're really saying here is that this type is ordered, which is to say values of it can be more or less than other values. There is some way to order a bunch of such values. So let's suppose we had that constraint. This would work perfectly, I promise you. The only problem is we don't know how to define ordered, right? So let's try. Let's say it's an interface, but what method set are we talking about? And we already know it's no methods. But here's the new thing that we can do, is instead of specifying a method set that the type needs to have, we can just give a list of types. We can just say, you know, we can say int float 64. That's not quite right, is it? You have to say type. Oh, I need to return something. Max. Fine. So this is what we can do, is we can create a new type of interface, let's just call it a constraint, which instead of being a method set is just a list of types which are allowable. So, you know, for t to satisfy the constraint ordered means it's either an int or a float 64, and we can just list all of the types that are in Go that support ordering. And it turns out that works, which is good. So over to the panel.
I have a question, just a quick one about the naming.
Yeah.
This ordered should be ordered because it comes to my mind orderable.
Orderable, yeah.
Something like this.
Yeah, I suppose it's like saying, you know, integers. Are they ordered or orderable? They are ordered, in fact, aren't they? Given any two integers, there is one and only one order into which you could put them, so that they were in order.
Is it actually any naming convention just proposed around this typical naming that we are working right now, that something is orderable and then it's advisable to use as a name of this type for interfaces?
Yeah, well, I think you can use whatever name you find clear, and I don't think there's a general rule that you can say it must always end in able or right?
Yeah.
You know, we have interfaces like stringer, which could also be stringable. You know, the convention is strongly towards stringer and friends, but that doesn't always make sense. You know, IO reader and writer follow that style, don't they? Yeah. But in some cases, that just is ludicrous or doesn't work, and we would have to say able. So this is fine, and the thing is, you know, there's actually a lot of types that you can write here. So there's int 32, int 16, int 8, float 64, float 32. Complex types are presumably orderable as well. So in order to save you having to do that every time, the proposal is that there be a new constraints package in the standard library which would define these. So we would probably say something like constraints.ordered. I think that's what's been proposed. So it would look like that. So you wouldn't have to ever do this yourself. There would just be such constraints provided for you, which is nice.
Does the proposal currently contain any other packages, like, you know, like a slices package or something along those lines, to build some of these for everybody? Some of these type of functions.
Well, that's an excellent question too, and I want to take a couple of minutes to discuss that. Like, what is the effect of all of this? But I want to first of all just sort of wrap up this part by saying this is it. Everything on screen now, you've seen everything that's being added to Go. It's essentially these two things. It's adding a list of type parameters and constraints in square brackets after the function name, and in some cases with the function call, and it's adding type lists as a new kind of interface you can write, and that's it. Is this less scary than people thought it might be or feared it might be?
I think it will be matter to get used to, and most important, not to overused.
Yeah.
So in this example here, we've said these things are sortable effectively.
Yep.
And then we've said only the following types are able to be sortable, and listed the ones where the Go language has a direct implementation of that.
Yeah.
Let's say we wanted to make a type called stringable or hashable or something like that.
Yeah.
Where we are going to have to bring the implementation ourselves for that.
Are you saying, Dave, that if you create a type called myType, could you list it in this list?
Yes.
Yeah, absolutely.
And then I have to bring my own functions to implement what ordered means for my type.
Yes, well, the thing is that, you know, your type would not be ordered because it's not a built-in type, but that's only because we're talking about this specific constraint. You could write any constraint you like as being an arbitrary list of types, including user-defined types. Does that partly answer your question?
So the short answer is you can write a type spec that is impossible to achieve, and you can include your own types within that. But could you implement an ordered?
Let's see what happens. I think that's an empirical question, isn't it? Let's define my type as something which
like
is not orderable. Yes, that's right. Just empty struct would probably be fine, wouldn't it? So this should work. No, it doesn't. Fine. So if we take this out, right. So that's the issue, isn't it? Is that the compiler knows that it can't. You're saying, in order to write this call, you're saying, am I allowed to call max with a slice of int? Well, is int ordered? Well, what does ordered mean? It means it's one of these types. Okay, yes it is, but I also have to verify, would it be okay to call it with any of these? And it would with this, but not with that. So we've done exactly what you said, haven't we, Dave? Is we've defined the constraint perfectly well. It's just that my type can never satisfy it. And the compiler knows that, so it won't let us get any further. Which is right, isn't it? We'd hate this to error at runtime. And we probably wouldn't be wanting to do anything like that, would we? It would be more like when we could ask, when would we define type list constraints, couldn't we? And I feel like we probably wouldn't, because if we're making our own types, we're probably putting methods on them, and then we can use a plain old method set interface as a constraint. And if instead we're interested in using those types with built-in operators, well, we can't do that. You can't make types which work with built-in operators like less than or whatever. That's just not a thing. If we call that operator overloading, that's not a feature of Go. So this doesn't make that situation any worse. We can put it that way, can't we? It doesn't take anything away from you. Maybe it doesn't add as much as some people would like. Clearly, so let's broaden the discussion out a little bit. Clearly, there's more that you could do along the lines of generic programming. But the Go team have decided not to do it. So, they haven't said what else could we add. They've said, what could we not possibly manage without? What would not reasonably be described as generics unless we had it. So that sort of fits with the general Go philosophy, doesn't it? Of trying to do the most with the least syntax, least amount of stuff for you to learn.
That's why I love Go.
Yeah, me too. So because
I philosophy as well.
Yeah, I'm an old man now, and it's hard for me to learn new things. So I really appreciate things which don't require me to learn a whole bunch in order to start using them to be productive. So that's great. And let's think about now. Firstly, what this is a fact on the ground now. So if we want to call ourselves Go programmers, we need to understand this. At least what's on screen. And that doesn't mean we have to write code like this. That's a different question, isn't it? We understand what the goto keyword does. That doesn't mean we use it. And same is true of lots of things in Go. But we need to be aware of it. So one question we might ask is how is this going to affect what people have to learn when they learn Go? How's it going to affect the way they write code? How's it going to affect the standard library, which was already asked, wasn't it? And maybe other things. So the first one we already covered, didn't we? So this is what you'll need to learn, is you'll need to learn what these type parameters are about, what constraints are and how they work, and how to write type list constraints and how to use interfaces as constraints, and also the comparable keyword. How will it affect the way we write code? Well, the funny thing is most of us have got by perfectly well up to now without this, haven't we? Because this came to Go late. I mean, I think the first public release of Go was 2010, something like that, wasn't it? And generics only came in let's say early 2022. So it's been a long gap. And most of us have got by. Some of us have complained vociferously and repeatedly on social media about the lack of generics. But in general, I think it's fair to say that most of those complaints have come from people who are not Go programmers. They're people who would maybe really like to use Go, except that they feel it's missing this crucial to them feature. So that discussion is now over and has been resolved in favor of generics. So it's here. So it's no longer useful to ask questions like, do we need this? Because we have it. So we might ask, do I need to use it now that it's here? Well, probably not. I mean, what do you think? What's the panel's opinion? Would anyone like to say, do they have a pain point right now which they're thinking, great, as soon as I have this, I can make my code a lot better? Or
I would ask first question: does it solve the readability of my code in code reviews? Because we can start adding this, and it could make actually code less readable and less obvious. That's my thought about this. Just to use for this feature, because we have this feature right now in the language, it's not necessary. Because it could obfuscate the code, to be honest.
Yeah, absolutely. And it's important to say, isn't it, that there are some things which you just simply can't write without the generic syntax like this. Or let's say it's supremely awkward to write. So readability is not an issue for those things because there is no alternative. There's no other way of doing this. So we can't say this would make code less readable because there is no such code right now. So that's the only option. But there must be quite a large class of problems, mustn't there, where we could use generics or not. So we have that choice. So should we automatically use generics wherever possible? I think is a question that's likely to be asked, isn't it? I feel like the answer is no. What do you think?
I feel exactly that no as well. See you, John.
That's kind of dangerous. Like you're going into a design without really looking at the problem. Like, oh, I'm going to use this. I'm going to use this feature in the design before you've even hammered out the design of the application.
Yeah.
I mean, it's a just like any other feature of the language, it's a tool to be used to solve problems. So to answer whether or not we're going to use it, I think depends on the problem and how you want to solve that problem. So an example of a place where it could be useful is one that I've come across multiple times, which is wherein some library I'm using is giving me back uncertain data. And I have to handle it. But the data could fit in some kind of, well, it's only ever going to be one of these three things, as an example. And I could then better define, instead of dealing with empty interface, I could better, and type asserting all over the place.
Yeah.
I could better, quarantine that kind of data in a place that's maybe more readable than what I have today. Again, like I haven't built that, so I can't prove it, but I suspect that would be a use case that could be common, depending on what you're doing.
Yeah, that's a great point. I mean, I think we can think about this two ways, can't we? There's functions where we're going to get some value that we don't know what the type is at runtime, an empty interface, let's say. And what we do with that value will depend precisely on what it is. If it's an int, we're going to do this. If it's a float, we're going to do something else. And a type switch is perfect for that. I mean, we would absolutely take empty interface and type switch on it, no question. This really wouldn't help us in that situation, would it? Because we could define a function that takes a t any, and then we would just have to do the type switch on it. So So it's almost two semi-opposite kinds of problem, isn't it? One where we want to do different things with any one of a number of type possibilities, or one where we want to do the same thing with a type, and we don't care what it is beyond knowing, let's say, whether we can compare it or whether it's ordered. So generics will make some problems that previously we had to go to annoying lengths to solve, let's say by unnecessary empty interfaces and type assertions, or horror of horrors, code generation. That's a thing too. I mean, suppose you wanted to write a generic container library, let's say, bunch in effect, and you have to write a whole bunch of code for bunch of int, bunch of float64, bunch of string, and code generation would be, until the advent of generics, would have been the only sensible way to do that, because you just have a million functions which are nearly the same except for the type they operate on. So that's a possibility. So it's, I would say, probably for people who use libraries as Go programmers, right, which is all of us, but a slightly larger set than the set of people who write libraries, or at least that anybody uses. So as library users, we might not even be aware that a function like max is generic, might we? It might just be, import John's super max library and just call max and give it whatever. I can write this program without having any knowledge of the syntax of generics, which is great. I mean, that's how it should be, isn't it? If that weren't true, we'd suspect that the Go team had got the design badly wrong. But I don't think they have. So it may be that, the majority of people just learn about this syntax in the sense that they can understand code that looks like this, but they never actually write such things themselves.
My main concern about it is that something like an influencer in the market or the open source community start to do like that, and new people learn Go start to follow these people, and then you have half of the community doing a way and another half doing another way. So that's just, let's say a couple of people define, okay, now we want the generics to be the way to go with Go, and they start to evangelize about it, and I don't know. That's my own concern.
Yeah, I sympathize with that. But of course there are already, differing opinions within the Go community about the right way to solve certain problems with Go. Some people are passionately of one opinion and other people passionately of the opposite, and that won't change. Nor should it, arguably. So this will just be another thing to bike shed about, let's say. But it's not like it's the first thing to bike shed about Go code, is it?
Let's go format, evidently.
Yeah.
So when I look at this, I think there's a couple of interesting points. So the code that I use, let's say we have this hypothetical Supermax library from John. The code that I use to consume that is just that little bit 21 to 24, and that doesn't really need to know anything about generics. It just has to work. So that piece is pretty simple, and from a library implementer's perspective, generics can be a huge advantage because you only have to do and test your logic once, and then the compiler should take care of ensuring that whatever constraints are required for the type should still hold, and compilers are really good at that, much better than people. Yeah. So that's a big attraction. I think the downside of this is in some cases, as the author of a library, you might make different choices for performance reasons. So the example I think of is in functional programming, we have things like map, where you iterate over, just like range really, over a given type and perform some operation on it. And we compose those really easily by having a type and a function, and you don't care as the author of this library what those two things are. You just know you're going to go through all of those types. But as the user of that library, there's a big difference between iterating over a small range of ints and iterating over an array where every item is let's say, a gigabyte in size. They're completely different. Your approaches to how to handle that need to be different. And the library author, so it's great, generics solve all of my problems, including the future ones.
Yeah, are you saying they might solve them too well, in the sense that, like the way ORM systems let you implicitly write horrendously non-performant SQL queries?
No matter how hard you try, you can't get away from it.
Yeah, exactly, and I think that's right. And I mean, I share some of those concerns, and maybe I can sum up the sense of the meeting by saying, clearly this is something which can be abused to create unnecessarily complicated and obscure code, or even non-performant code, or whatever. And that's true already of other things other than generics. So is this significantly worse in that respect than those things? I don't think so. And I also think gophers are pretty sensible in general. And I think the way that Jakub phrased it earlier was exactly the right one, is basically, if it makes the code clearer, great. You know, for me personally, when I'm writing code, I'm thinking, should I use generics here? Of course I will use them for everything for a while. Just like, you know, when you discover Go routines, you're like, brilliant, let's have Go routines everywhere. And then you kind of work that out of your system and you become a bit more measured about it. So it'll be like, if using generics makes this program easier and simpler, I will absolutely use them. If it doesn't, well, that would be silly, wouldn't it? So that's great. And one final point that we might make before we wrap up is just to say, clearly there are some things in the standard library where generics could be very useful. We already have a sort of attempt at a generic container package, so you have container/ring, container list, and so forth, but nobody uses those because they're not really generic. So it's sort of a halfway house. And clearly now we will be able to have totally generic containers. So I think there will be a new slices package for symmetry with strings and bytes and so forth. Perhaps a maps package. And we can do things like Dave mentioned, map and its companion reduce. We'll be able to have those. We'll be able to have min and max, of course, and first and last, and all of these good things. And people will finally be able to stop complaining on Twitter that these things aren't provided in the standard library because they so hate to write 5-line for loops like this. But they'll be there, which is great. And nothing will change in the standard library in the sense that, you know, it won't be like APIs that you're used to working with will suddenly work a different way because of generics. That won't be true, or at least not, it won't break backward compatibility. So, you know, stuff that compiles now will compile with generics and work the same way. What they'll probably do is add new things, right? They'll add new generic alternatives or extra things to the standard library, which would be kind of nice.
Now time for practice.
Yeah, I think we're content, aren't we? So let's go forth and play with generics. And I might just mention that I'm using the Go-To playground here, which is just like the regular Go playground, but lets you write generic code like this. And you can even, if you're happy to check out Go from source and build it yourself, you can build on the branch where they're developing generic support, so you can try it.
There is no even release candidate yet?
Not yet. I think the current thinking is that they would like to target Go 118 for the first hints of generic support, which would be approximately February 2022, wouldn't it? I suspect that's probably a bit ambitious. I think what's going to happen is, you know, we really don't know what code is going to look like and what ideas people are going to come up with to use generics. And the same has happened with other features in Go, you know, that things were originally designed a certain way, and then people thought of ingenious or brilliant or horrendous uses for them, and things have been modified on the basis of that learning. I'm sure this will be the same, and I'm sure people will discover wonderful new ways to use generics, which are very beautiful, and we'll all want to use them. And they'll also come up with horrible, horrible anti-patterns, which will become code review comments like, don't do that with generics. That's a major foot gun. So it'll be fun finding all of that stuff out. And we look forward to seeing what happens. So thanks very much, everybody, for being here. It's been a great session. And I will see you all next time.
Thank you.
Thank you.